In this part of the video, I'm going to try to demonstrate how to use Andrew Hayes' process macro in SPSS. And remember, this macro is available on Andrew Hayes' website. So just visit processmacro.org to find the instructions on how to download the macro. And here's a screenshot of what that website looked like, at least in the summer of 2023. And from there, I clicked on through to this University of Calgary website that has a download button for the current version of process. And so that allowed me to download both the R file that defined the process function in R earlier in this video series, and a similar file that defines the process function in SPSS. I used this function in R to write the robot's data frame to a CSV file so that I could open it in SPSS. And before opening an SPSS, I just want to remind you what a CSV file is. It's a comma-separated values file, and on most operating systems, if you just try to open a CSV file directly, it will probably use your default spreadsheet software, such as Microsoft Excel, to provide you with a visual representation of the data contained in that spreadsheet. So here we have this rectangular data set with transport, material, color, mass, battery, price, 3 ratings, and the legs variable. But this is maybe a more direct representation of what the data contained in the CSV file look like. So here I've opened the CSV file in a text editor, and you can see it's just plain text where the first line of text includes a series of variable names separated by commas, and each subsequent line of text provides the actual observed data for each row of the data set in the same order as the variable names given in the first line of text, and again separated by commas. And when you import a file like this into SPSS, it's going to bring you to a dialog box like this, the text import wizard. You can click next on the first dialog box to get to the first place where you actually specify information about how to import the data. This is a delimited file. It has a comma separating each value. There are variable names at the top of the file, and the period is the decimal indicator, so all of those defaults are fine. All of the defaults on this screen are also fine. On this screen, I need to specify that it's a comma-separated file. I think that's the default as well. And the text qualifier is a double quote. That's probably also the default, but it's good to make sure. And after this, you could specify the type of each individual variable, but in this case, I don't need to because I'm only going to be working with the numeric variables in this session. So after clicking through the remaining dialogues, I get a data set like this that resembles what the preview looked like in Excel and what the data frame we know from R looked like. To make the process macro available in SPSS, I have to open the process.sps file that I downloaded from Andrew Hayes' website and run all of the code in it. One of the ways to run all of the code is simply to go to the Run menu and then choose All. And then you'll get an output window like this that will tell you when the macro definition file is finished running and the process macro is available for use. You'll notice that the transport, material, and color variables got imported just as strings, but that doesn't matter because I'm not going to use any of them. I have the legs variable right here, and I have rating.fun, and I have price, and those are all I really need. To run the process macro, I need a syntax file. So I'm going to go File, New Syntax to have a blank code file, and then I'm going to write out this line of code. Process is the name of the macro, and then it has these arguments that are specified in this funny way that SPSS uses for its function arguments. So the first one is called y, and that's the name of the variable I want to use as the response variable, price. And then you use a slash to start a new argument, and the next one is called x, and that one should be the name of the variable that I want to use as the initial predictor, the legs variable. The final variable related argument m is the name of the variable I want to use as the mediator, rating.fun. Just like in R, I have to specify that I'm using model 4, and that I want 5,000 bootstrap samples. Then when I run that line of code, I'm going to get an error message telling me that variable names should be no more than 8 characters in length. I'm showing you this because I assume that every time you try to use this macro in SPSS, you are going to see this error message before you remember that it has this really obscure restriction. So I'm going to go back to my code. I'm going to use rename variables to rename the rating.fun variable to simply fun so that it will be shorter than 8 characters. Then I'm going to run that line of code, and you can see that it actually did change the name of the corresponding variable in the data view in the background here. And finally, I can change the syntax that I used for the process macro so that I have fun instead of rating.fun. And then I'll be able to run the process macro again, and this time all three of my variable names are less than 8 characters long, so I won't get the error message. The output looks very similar to what we saw in R. We have some general information at the top, we have the summary output of the two regression models in the middle, and if you scroll down to the bottom, you're going to see the key piece of information, which is the section that gives you bootstrap confidence intervals for the direct and indirect effects. And the one we care about is the indirect effect, which, consistent with all of the other examples that I've talked about today, is estimated as 5.145, because that's just the product of the A slope and the B slope. That is never different. But here we get a new bootstrap confidence interval ranging from 3.37 to 7.05. But there's one more thing I should do. Previously, I did not specify that I wanted to use bias-corrected confidence intervals. So I can add that argument, BC equals 1, just like in R, and run the process macro again, scroll to the bottom, and see slightly different confidence interval for the same indirect effect.